Hi, now I'm here to explain about the transmission of digital data. In this transmission of digital data, the first topic is digital data transmission. First of all, we have to know that what is meant by data transmission. That means data transmission is the process of transferring the analog or digital data over a communication medium between the two or more devices, and it is also known as digital data transmission is also known as digital communication or digital transmission. And the data transmission is can be an analog and digital, but it is mainly reserved for sending and receiving the digital data, and it works when a device intends to send the data to one or more multiple devices like a computer or the server, and it is in the form of discrete signals or digital bits. That means data is transformed in the form of bits, that means or signals, between the two or more devices. These signals or bits are placed over a communication medium such as optical fibers or copper wires, etc., for delivery to the destination device. And each signal or bits can be a passband signal or the baseband signal. And in addition to communication, data transmission may be carried to a device. And for example, RAM means random access memory, or hard disk, they both send the data to the processor. So this is these two are also the form of the data transmission. In this data transmission, it is classified into two transmissions. First one, serial transmission, and next one is parallel transmission. And this serial transmission is further divided into two transmissions: synchronous transmission and asynchronous serial transmission. First one, serial transmission. Yes, serial transmission. In this serial transmission, it sends the data bits one after the another over a single channel. And serial transmission is normally used for long distance data transforms. And in this serial transmission, bits are sent sequentially on the same channel, which reduces the cost. That means it requires only one wire, and it reduces the cost of this whole transmission. And this one wire is used to transfer the data from the sender to the receiver, and the 8 bits are sent one after the another. That means first 0 will be sent to the receiver, and next 1, and next 1 and 0. That in this process, all the 8 bits are sent to the receiver one after the another, and it so it reduces the cost, and also it slows the speed of the transmission also. And for serial transmission, some time is needed because bits must be assembled and sent as a unit. Bits must be assembled and sent as a unit to the receiver, and it ensures that data integrity is maintained as it transmits the data bits in a specific order. And it requires the interface converter. That means this is the interface converter. It stores the 8-bit data, and it will send the 8-bit data one after the another, and it receives the 8-bit data one after the another in a sequential order, specific order. And in this serial transmission, there are two serial transmissions. First one is synchronous serial transmission and asynchronous serial transmission. In synchronous serial transmission, groups of bits are combined into a frames, and that frames are sent continuously with or without the data to be transmitted. And in asynchronous serial transmission, groups of bits are sent as independent units with start or stop bits, and no data link was synchronized in the asynchronous serial transmission. First one, asynchronous serial transmission. In asynchronous serial transmission, data bits can be sent at any point in time, and start bit and stop bit and gaps are used to transfer the bits between the data bytes to synchronize the transmitter and the receiver. And it is used to ensure that the data is transmitted correctly or not. And it sends one start bit 0 at the beginning, and one or more stop bits 1 at the end of the each byte, and it is cheap and effective. Example of this asynchronous transmission is the connection of the terminal to a computer, and this is the direction of flow in which data will be flow in this direction, and this is the sender and the receiver. In between the sender and receiver, the data will be flows through the transmission medium. In between these data units, gaps are used, and the time between the sending and receiving data is not constant, so gaps are used to provide time between the transmission. And the advantages of this asynchronous serial transmission is that no synchronization is required between the transmitter and the receiver devices, And the disadvantages of this asynchronous transmission is that data transmission can be slower, but this is not always in the all cases. And the next serial transmission is synchronous serial transmission. In this synchronous transmission, it sends the bits one after the another without start and stop bits or gaps, and it is the responsibility of receiver to group the bits. That means it is the sender and it is the receiver. This is the direction of flow in which the data is flows in this direction, and sender will sends the data to the receiver. These are the 8 bits, and we have to group the bits without any gaps, and this transmission is used to group the bits of the to send the receiver. And next the receiver counts the bits as they arrive and groups them into a 8-bit units. And in this synchronous serial transmission, data bits are transmitted as a continuous stream in time with master clock, and the data of transmitter and the receiver both operates using a synchronized clock frequency. So therefore start bits, stop bits and gaps are not used in this synchronous serial transmission. And this means that data moves faster and timing errors are less frequent than the asynchronous serial transmission, because the transmitter and the receiver time is synchronous in this serial transmission. And the example of this synchronous serial transmission is connection between the computer and a modem using some particular protocol. And difference between the asynchronous serial transmission and the synchronous serial transmission means, in synchronous it sends the bit one after the another without start and stop bits or gaps, but in asynchronous transmission it sends the bits one after the another with start and stop bits or gaps, with start or stop bits and gap, without start and stop bits or gaps. This is the difference between the asynchronous and the synchronous transmission. And next transmission of data transmission is parallel transmission. In this parallel transmission, it sends the multiple data bits at the same time over the multiple channel. This means data can be sent much faster than the serial transmission. And in this parallel transmission, multiple bits, usually 8 bits or a byte or a character, are sent simultaneously within the same cable, and it's synchronized to a clock. That means here sender and the receiver, we already know the sender will send the data to the receiver. Here we have 8 lines and we have 8 bits to send, and these 8 bits are sent together at the same time over the multiple channels. That means if we have a 8 bits, so we need 8 lines. If we have a 4 bits to send together, then we need 4 lines. If we have a infinity bits to send together, then we need infinity lines. And at the same time over the multiple channel, it will send the multiple data bits to the receiver. And this is the use of the parallel transmission. And the parallel devices have a wider data bus than the serial devices, and it can therefore transfer the data in the words of the one or more bytes. And as a result, there is a speed up in the parallel transmission bitrate than the serial transmission bitrate. And however, this speed up is trade off versus the cost, and since we using several, that means multiple channels, its cost is more than the serial transmission, because in this we are using the multiple wires. In the serial transmission we are using only one wire, but its speed is fast. Its speed is slow, because it will send at the same time. It will send at a it will take the more time to send the data one after the another. And the example of this parallel is connection between the computer and a printer is the example of this parallel transmission. And at last, techniques to increase the performance of serial and parallel transmission includes using better transmission medium such as optical fiber, cables or repeaters, etc. This is all about the serial and parallel transmission. That is nothing but transmission of digital data. Thank you.